y equals 2 to the x power. This is an exponential function because the variable is exponent. Domain is all real numbers. Let's make a table. 0, -1, -2, 1, 2. 2 to the 0 power 1, 2 to the negative first power 1/2, 2 to the negative second power 1/4, 2 to the first power 2, 2 to the second power 4. Plot these points. Then connect these points smoothly. Y equals 0 is the horizontal asymptote line. So range is from 0 to positive infinity. 0 is exclusive. Since the function is not symmetric about y-axis, it's not symmetric about the origin. It's not odd or even function, neither. One-to-one function. Let's draw any horizontal line passing through the graph. We only have one intersection. It's a one-to-one function. And behavior. When x approaches negative infinity, f of x approaches 0. When x approaches positive infinity, f of x approaches positive infinity. From left to right, the graph goes up. So it's an increasing function. Increasing interval, all real numbers. No decreasing interval. Y equals log base 2 of x. This is a logarithm function. Domain, since these two are inverse function to each other, domain and range will be switched. For logarithm function, range is all real numbers. Domain is from 0 to positive infinity. 0 is exclusive. Look at the table. We need to switch x, y. -2, -1, 0, 1, 2. 1/4, 1/2, 1, 2, 4. For exponential function, we have y equals 0 as a horizontal asymptote line. So x equals 0 is the vertical asymptote line for logarithm function. 1, 0, 1/2, -1, 1/4, -2, 2, 1, 4, 2. Then connect these points smoothly. Since the graph is not symmetric about y-axis, not symmetric about the origin, it's not even function or odd function, neither. Let's draw any horizontal line. We only get one intersection. Yes, it is a one-to-one function. X cannot be approaches negative infinity. X approaches positive infinity. F of x approaches positive infinity. X approaches 0. F of x approaches negative infinity. From left to right, the graph is going up. So in his domain, it's an increasing function. Increasing interval will be the domain from 0 to positive infinity. No decreasing interval. Y equals 1/2 to the x power exponential function because the variable is exponent. Domain is all real numbers. 0, -1, -2, 1, 2. 1/2 to the 0 power is 1. 1/2 to the first power 1/2. 1/2 to the second power 1/4. 1/2 to the negative first power. We do the reciprocal. 2 to the first power equals 2. 1/2 to the negative second power equals reciprocal of 1/2 is 2/1 squared equals 4. Plot the points. Horizontal asymptote line. Y equals 0. Connect these 5 points smoothly. Range is from 0 to positive infinity. Same as 2 to the x power, neither. Same as 2 to the x power, it is a one-to-one function. And behavior. As x approaches negative infinity, f of x approaches positive infinity. X approaches positive infinity, f of x approaches 0. Left to right, the graph is going down. So, no increasing interval in its domain. Decreasing interval is all real numbers. Y equals log base 1/2 to the x power. This is a logarithm function. Since these two functions are inverse to each other, we need to switch domain and range to get domain and range of this logarithm function. Domain from 0 to positive infinity. Range is all real numbers. Switch x, y. 4 to 1, 1/2, 1/4. -2, -1, 0, 1, 2. For exponential function, we have y equals 0 as a horizontal asymptote line. So x equals 0 is the vertical asymptote line. For logarithm function, plot these 5 points. Connect these points smoothly. Neither. Yes. As x approaches negative infinity, cannot approach negative infinity. X approaches positive infinity, f of x approaches negative infinity. X approaches 0, f of x approaches positive infinity. From left to right, the graph is going down, so no increasing interval. Decreasing interval is the domain from 0 to positive infinity. Y equals sin x. This is the sine function. Domain is all real numbers. Range is an inclusive interval between -1 and 1. Let's plot the points. 0, 0. 90 degree 1, 180 degree 0, 270 degree negative 1, 360 0. Keep going the same trend. Then connect these points smoothly. Since the graph of a sine function is symmetric about the origin, this is an odd function. When we draw any horizontal line, we have more than one intersection. So this is not a one-to-one function. Y equals cosine x, cosine function. Domain is all real numbers. Range is an inclusive interval between -1 and 1. Plot the points 0, 1, 90, 0, 180, -1, 270, 0, 360, 1. Keep going the same trend. Then connect these points smoothly. Since the graph of a cosine function is symmetric about y-axis, this is an even function, any horizontal line. We got more than one intersection. This is not a one-to-one function. Y equals tangent x. This is a tangent function. Domain x cannot be 90 degree, 270 degree, 450 degree, and so on. We can use x is not equal to 90 degree plus k times 180 degree. This k is integers. Range is all real numbers. First of all, let's draw the vertical asymptote line. Zero, 0, 45, 1, -45, -1. Keep the same trend. Since the graph is symmetric about the origin, this is an odd function. It's not one-to-one function because when we draw any horizontal line, we got more than one intersection.